Welcome everybody. This is our second session in NEET previous year question for chapter Dual Nature of Matter and Radiation of class 12th. Before this video, we have covered one video in this for this chapter and a lot of other videos related to previous chapters. And all of those videos are available on our YouTube channel's playlist section. If you have not watched those videos, then you can go to channel's playlist section and find those videos. If you find these videos helpful, useful, then do press the like button, share them, and subscribe to our channel. It helps a lot when you share and subscribe. Also, if you like to donate us something, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. With this, let's start today's video. In the previous one, we covered up to question number 20, I think. So we will start with 21. So this was the last question. Now we will start with 21. So when a light of 2 mu node, where mu node is the threshold frequency, is incident on a metal plate, the maximum velocity of electron emitted is V1. When the frequency of incident radiation increased to 5 V node, the maximum velocity of the emitted from the same plate is V2. The ratio of V1 and V2 we have to find out. So we know that for a photoelectric effect, we can write that maximum kinetic energy is equal to h times the frequency minus work function. So initially it is V1 and frequency of the incident light is 2 mu naught. So it will be half m V1 square is equal to h 2 mu naught minus 5. And similarly for the second case, it is half m V2 square is equal to h5 nu node minus 5. Now we can write this expression like this, that if we divide both of these, we will get v1 square by v2 square is equal to 2h nu node minus 5 divided by 5h nu node minus 5. Now this can be further solved as v1 by v2 will be equal to under root of, and let's cancel out h nu node by taking it common. So we will get 2 minus 5 by h nu node divided by 5, uh, 5 minus 5 by h nu node. Now threshold frequency is nu node, means work function phi will be equal to h nu node because this is the threshold frequency. So phi by h nu node will be equal to 1, and this will be 1 and this will be 1. So this will be 2 minus 1 divided by 5 minus 1. So this will be basically 1 by 2. So the ratio of V1 to V2 will be equal to 1 by 2. That is option C for us. Now let us move ahead. The photoelectric threshold wavelength of silver is given by this number. The velocity of the electron ejected from the silver surface by ultraviolet light of wavelength. So we have to find out velocity, and that can be calculated as we know that kinetic energy maximum will be equal to h nu minus phi. So here I think threshold wavelength is given to us here. So threshold wavelength is given, so from that we can calculate the work function. So work function will be equal to hc by lambda threshold. So hc is 1240 electron volt nanometer, and lambda threshold is 325 into 10 raised to power minus 10, and that can be written as 325 into 10 raised to power minus 9 meter. Now nanometer and minus 9 are same, so they get cancelled, and this will give us 3.82 electron volt. So this is the basically work function. Now energy of the incident radiation can be calculated using similar formula, that hc by lambda, that will be 1240 electron volt nanometer divided by, that is 253.6 nanometer from this, and nanometer again gets cancelled out, and energy comes out to be 4.89 electron volt. So maximum kinetic energy Ke max will be equal to 4.89 minus 3.82, and that is basically in electron volt. So what we have to do, we have to convert it. So we can write that kinetic energy will be half mv square, and this will become 1.07 electron volt. So that let us convert it into joules. So that will be 1.6 into 10 raised to power minus 19 in joules. Now from this, v square will be equal to 2 into 1.07 into 1.6 10 raised to power minus 19 divided by mass. That will be 9.11 10 raised to power minus 31. So now if we solve only for the power, so what we will get? We will get V is equal to under root of 2 into 1.07 into 1.6 divided by 9.11 into now 19 plus, we can say basically 31 minus 19. This will give us 2 and, oh sorry, 12. 12, and we have under roots, so we will get 10 raised to power 6. So yeah, now all the options have 10 raised to power 5 or 6. So basically, this option can be rejected. Option C can be rejected, as this is 61 into 10 raised to power 3. Now we have to calculate or solve for this one. Now to solve to approximate this one, what we can do here? Now 2 into 1.6 will give us 3.2, and into 1.07 is there, so let us assume that is 3.3 divided by 9, and we have under root for that. Now this can be written as 33, this can be written as 33 by 90 and under root, so that will be 11 by 30 basically, and under root of that. Now under root of 11 will be something like 3 point, let's say 1. We are approximating here. And under root of 30 will be something 5.1, let's say. Now again approximate it to 3 by 5, and that will give us 0.6. So 0.6 into 10 raised to power 6. That should be the nearby answer. And so let's say 0.6 into 10 raised to power 6. Now this can also be written as 6 into 10 raised to power 5. I think, yeah. So these both answers are matching here. So either A or B can be the right answer here. Now let's move ahead to the next one, 23rd. Photons with energy 5 electron volt are incident on a cathode C on a photoelectric cell. The maximum energy of the emitted photoelectrons is 2 electron volt. Then photon of energy 6 electron volt are incident on C. No photocurrent photoelectron will reach the anode A if the stopping potential of A relative to C. Now initially photon energy is 5 electron volt, and the energy of the electron is 2 electron volt. So we can write that Ke max is equal to h nu minus 5. Now Ke max is 2 electron volt and h nu is 5 electron volt minus 5. So from this 5 is 3 electron volt, means work function is 3 electron volt. Now when photons have energy 6 electron volt, then their maximum kinetic energy will be 6 minus 3, that will be 3 electron volt, and that should be equal to E times the stopping potential. So E gets cancelled and stopping potential is 3 volt here. Now one thing to remember here, that this Vs is always negative because stopping potential has to be, it is a retarding potential. So answer will be minus 3 volt, not plus 3 volt. So that is option D. So option D is the right answer. If you have observed the graphs carefully for the stopping potential, we know that stopping potential, for stopping potential, graphs meets on the negative x-axis. So it has to be along the negative axis. So let's move ahead. A photoelectric surface is illuminated successfully by the light of wavelength lambda and lambda by 2 if the maximum kinetic of energy of the emitted photoelectron in second case is 3 times the first, the work function of the surface of the material. So we have to find out work function here. So The formula for photoelectric effect we have already, that Ke max is equal to hc by lambda, that is basic energy of the incident photon minus the work function. So for lambda, the kinetic energy of the electron is in second case is 3 times. So let's say in the first case it is V1, it is Ke1 is equal to hc by lambda minus 5. In the second case, let's say it's Ke2, and that will be hc by lambda by 2 minus 5. And this can be written as Ke2 is equal to 2hc by lambda minus 5. Now if we divide the both of these, so Ke2 by Ke1 will give us 2hc by lambda minus 5 divided by hc lambda minus 5. Now this is equal to 3. So if we cross multiply, then we will get 3hc by lambda minus 3 5 is equal to 2hc by lambda minus 5. And from this we can write that hc by lambda is equal to 2 5, and basically phi is equal to hc by 2 lambda. That is option A for us. Moving ahead, when the energy of the incident radiation is increased by 20%, the kinetic energy of the photoelectrons emitted from the metal surface increase from 0.5 to 0.8 electron volt. The work function we have to find out. So again we can use that Ke max is equal to, or h times frequency minus 5. Now this can be written as Ke max is equal to energy of the photon minus 5, because here it is mentioned that energy is increased by 20%. So initially we have 0.5 electron volt is equal to energy E minus 5, where phi is the work function. And after that we increase the energy by 20%, so this becomes 120 E by 100 minus 5. So now what we can do? Now we can divide both of these. So we will get 5 by 8 is equal to E minus 5, and divided by 0 gets cancelled. This will be 6 by 5 of E minus 5. Cross multiplying, we will get 6E minus 5 is equal to 8E minus 8 5. So this will give us 3 is equal to 2E, and basically phi is equal to 2 by 3 of E. Now we can use this expression here. So zero point 0.5 electron volt is equal to, we have to calculate work function, right? So let's find out value of E in terms of work function, and that will be 3 phi by 2. So that will be, substituting value of E, this will give us 3 by 2 of phi minus phi. So 0.5 electron volt is equal to half of phi, and phi will be equal to 1 electron. That is option B for us. Let's move ahead. For photoelectric emission of certain metal, the cutoff frequency is nu. If radiation frequency too nu impinges the metal plate, the maximum possible velocity of the emitted electron will be. So we have to calculate maximum possible velocity. So for that, we can use that maximum kinetic energy, or half mv square is equal to energy of the photon. Uh, let's say that is h nu minus phi. So initially, as mentioned here, that cutoff frequency is nu. So we can write that phi is equal to h nu, and frequency of the incident radiation is 2 nu. So this formula will become half m v square is equal to 2 h nu minus h nu. So half mv square is equal to basically h nu, and velocity will be 2h nu by m under root. That is option C for us. Let's move to the next one. Two radiations of photons, 1 electron volt and 2.5 electron volt, successively illuminates a photosensitive metallic surface of work function zero point 0.5 electron volts. The ratio of maximum speed. So we know from the relation that maximum kinetic energy of the photon is given by h nu, where h nu is the incident energy minus the work function. Now Ke max can be written as half mv square is equal to h nu minus 5. So for the first one, we can write that half mv1 square will be equal to 1 minus zero point 0.5. So that will be 0.5 electron volt. And for the second, we can write half mv2 square is equal to 2.5 minus zero point 0.5. That will be 2 electron volt. So if we divide both of these, we will get V1 square by V2 square is zero point 0.5 by 4, that is 1, zero point 0.5 by 2, that will be 1 by 4. And from this, V1 by V2 will be equal to half. And that is option B for us. Now with this, let's move to the next one. The threshold frequency of a photosensitive material is given by this value. Frequency of light is this. The cutoff voltage for the photosensitive material is nearly, we have to find out. So we know for the photoelectric experiment that E times the stopping potential is equal to h nu minus the work function. Now this has to be in electron volt. Both energy and the work function has to be converted in electron volt. So how can we do that? And for that, first we will find out this term and then we will convert into electron volt. So EVS will be equal to h nu, that is h times frequency of incident light, that is 8.2 10 raised to the power 14, minus work function, that will be h times the threshold, that is 3.3 into 10 raised to the power 14. And now we can take h common, and this will be 8.2 minus 3.3, and that will be equal to 4.9 into 10 raised to the power 14. Now from this, Vs will be equal to value of h is 6.626 10 raised to the power minus 34 into 4.9 into 10 raised to the power 14 divided by value of E, where that is 1.6 into 10 raised to the power minus 19. Now minus 19 and 14, they will get added, and this will give us 33, 10 raised to the power 33. So basically we will be left with 6.626 into 4.9 divided by 1.6 into 10 raised to the power minus 1. Now what we can approximate that this will cut approximately on 3, and from this we will get around 20 into 10 raised to the power minus 1. So that will be approximately 2 volts. That is option A for us. Now let's move to the next one. The work function of a surface of a photosensitive material is 6.2 electron volt. The wavelength of incident radiation for which stopping potential 5 volts lies in the UV, infrared, visible or X-ray. So for this question, to able to solve this question, we should have the basic understanding about region. So we know that our visible region lies between 400 nanometer to 700 nanometer. Now, if some light has a wavelength lesser than 400 nanometer, means it has a higher frequency, so it lies in ultraviolet. And if some light has a wavelength greater than 700 nanometer, then it lies in infrared. So this is the our, we can say, key point here to find out that in which region it lies. So from the from the photoelectric effect, we know the relation that E times Vs is equal to energy minus work function. Now stopping potential is 5 here, so this will be 5 electron volt, because this is 5 volt and we have E, so 5 electron volt is equal to E minus work function, that is 6.2 electron volt. So from this, value of E is 6.2 plus 11, that plus 5, that is 11.2 electron volt. Now we know that energy is hc by lambda. So from this, lambda is hc by e, and hc is 1240 electron volt nanometer divided by 11.2, and let us assume this is 11 basically. So that will give us 1240 divided by 11. So 14, 1, 3, let's say 3. So we will get 113 nanometer approximately. Now 113 nanometer lies below 400 nanometer. So light will be at least in the UV region. So infrared is not possible, visible is not possible. So either it can be in UV or either it can be in X-ray. Normally X-ray has a wavelength of in the angstroms or in the few nanometers. So X-ray cannot be answer. Only option A, UV is the right answer or possible answer. Now, when a photon of energy h nu falls on an aluminium plate of work function E node, photoelectrons of maximum kinetic energy K are ejected. If the frequency of radiation is doubled, the maximum kinetic energy of the photoelectron will be. So we have to find out maximum kinetic energy for the second case. From the photoelectric experiment, we have relation that kinetic energy is equal to h nu minus work function. So for the second case, when we double the frequency, let us it is Ke dash, so it will becomes 2h nu minus 5. Now let's divide both of these, and work function here is E node, and E node value is not given. So let us say it is as it is. So I have to write work function as E node. Let us keep it as it is. So if I divide both of these, so Ke dash by Ke will be equal to 2h nu minus E naught divided by h nu minus E naught. So I think from this we will not be able to solve. Yeah, we can do another thing here also. That I can write this term Ke dash like this, h nu plus h nu minus E naught. Now this term h nu minus E naught is equal to Ke dash. Oh, sorry, Ke. So Ke dash will be h nu plus Ke. So here it is. Option A will be the right answer here. Now let's move to the next one. The work function of a metal A, B, C are respectively 1.92 electron volt, 2 electron volt, and 5 electron volt. According to Einstein's equation, the metal which will emit photoelectron for the radiation of wavelength 4100 angstrom is R. So we know for electron emission, the energy of the radiation should be greater than the work function, or at least it should be equal to the work function. So we have the energy, we have the radiation of 4100 angstrom. So what I can do, 4100 into 10 raised power minus 10 can be written as 410 into 10 raised power minus 9, or basically 410 nanometer. So from this we can calculate energy. Energy will be hc by lambda, that will be 1240 nanometer electron volt divided by 410 nanometer. Nanometer gets cancelled, and this will roughly gets cancelled on 3. So our energy of the radiation is 3 electron volt, and this 3 electron volt is greater than 2 electron volt and 1.92 electron volt. So both of these will emit electron, and 5 electron volt metal will not emit electron. So A and B only will be the right answer here. That is option C. In the next one, a photosensitive metallic surface has a work function of h nu node. If the photon has energy 2 h nu node falls on the surface, electrons come out with maximum velocity of 4 into 10 raised power 6 meter per second. When photon energy is increased to 5 h nu node, then the maximum velocity of the photoelectron we have to find out. So we can write that half NV1 square, that is basically kinetic energy, is equal to 2 h nu node minus h nu node, because we know the V1 velocity V1 is known. known to us. Now for the second case, we can write half mv2 square is equal to 5 h nu naught minus h nu naught. Now if we divide both of these equations, what we will get? We will get v1 square divided by v2 square is equal to 1 by 4, and from this we will get that v2 is equal to twice of v1. So twice of v1 will be equal to 2 into 4 into 10 raised to power 6. This will be 8 into 10 raised to power 6. That is option C. So option C is the right answer here. Now let us move to the next one. Question number 33. According to Einstein's photoelectric equation, the graph between kinetic energy of photoelectron ejected and frequency of incident radiation. So we know that kinetic energy is equal to hf minus phi. So here this is a constant term. So I can write like this, that y is equal to mx plus c. Here y is equal to kinetic energy, and m, that is slope, basically that will be equal to Planck's constant. So slope cannot be zero here. So it will be inclined because slope basically is equal to tangent theta, and here this has some value. So this has to be some inclination, and we can say x will be frequency, and there will be some negative constant also, means at y is equal to 0. Suppose when y is equal to 0, then we will have mx plus c is equal to 0. So from that, what we can write? We can write that x will be equal to minus c by m. Now this c is already negative because here we have taken positive and here is negative. So basically c is equal to minus of phi. So this will become minus minus plus phi by m, and where m is h, so this is basically phi by h. So at y is equal to 0, we have positive value of x, that is phi by h. So this is not possible because at y is equal to 0, x is 0. This is not possible because at y is when y will be 0, if we extrapolate like this, then x will be negative here, and this is also not possible because here we have inverse slope. So only option D is possible here. So with this next one, when ultraviolet rays incident on a metal plate, then the photoelectric effect does not occur. It occurs by incident of. So here it is mentioned that UV radiations are getting incident on the plate, and there is no photoelectric effect. Means energy of the ray is less than the work function. So we need rays with higher energy, and higher energy here, infrared does not have higher energy than UV, radio does not have, light wave does not have, only X-rays have. So X-ray will be the right answer here. Now, a light source is a distance d from the photoelectric cell. Then the number of photoelectrons emitted from the cell is n. If the distance of light source and the cell is reduced to half, the number of photoelectrons emitted will become. So it is mentioned that distance is reduced to half, and we know that number of photoelectrons I and E is proportional to intensity, and intensity is proportional to basically 1 by r square. So we can write that Ne, or let's say N1 by N2 will be equal to R2 square by R1 whole square, R2 by R1 whole square. Now it is mentioned that initially, suppose if initial distance was D, then our final distance is D by 2, because distance is uh, reduced to half. So let's say R1 is initial distance and R2 is the final distance. So this will give us N1 by N2 is equal to 1 by 4, and or N2 will be equal to 4 times the N1. So number of photoelectrons emitted will become or increase fourfold, or 4 times. And let's do one more for this video. Einstein's work on photoelectric effects gives support to that E is equal to E is equal to half mc E is equal to mc square, E is equal to h nu, E is equal to h by lambda, and h nu is equal to half mc square. So basically option C and D are the wrong relation, and option A and B are the right relation here, but option A is related to theory of relativity, and that does not come in under photoelectric effect. So option A is also neglected. So option B is the only right answer here. So with this, we end this video here. Hopefully you have understood it well and you liked it. If you find it useful, then do press the like button, share it, and subscribe to our channel. And if you like to support us, then do scan these QR codes. With this, we end this video here, and we will meet in next video.